Hey, in this video, we're going to be talking about long division and shortcuts when dealing with larger divisors and dividends. Sometimes when we come across a long division problem that involves numbers of 2 or more digits, it can be a little overwhelming, especially when you have to keep track of the steps going up and down and around and then going back up again, figuring out what goes where. Well, this is an example I'm going to give you here to show you how you could do it, how you could break it down, and it not be so overwhelming to you. All right, here's the problem that we have. We have 63 and 495. 63 on the outside of the bar, here's the divisor, and 495 under the bar, inside the bar, is going to be your dividend. And we have to figure out how many times 63 fits into 495 without going over. This may involve remainders, which of course are leftovers, and if that's the case, so be it. Let me show you some steps to break it down so it doesn't look so overwhelming. All right, the first thing we're going to do is look at the divisor, 63. We're going to take that number and we're going to round it. Now, since it's a two-digit number, we know the highest place value it has is the tens place. The 6 is really a 60. So the question becomes, what does 63 round to the nearest 10? Well, if you do your little rule of 5 to the sky, 4 to the floor, you will see that 63 rounds down to 60. So in the corner here, I'm going to have my little backup notes. I'm going to make a 60. All right, I'm also going to make the bar for you. Now, underneath that bar, I'm going to copy the dividend, which is 495. All right, so now it's 60 and 495. The 495 stays. Now, we still have two large numbers, so what are we going to do to shrink them down? Well, it's very simple. We're going to eliminate the ones columns on both numbers in this section right here. We're going to eliminate the 1. So in the 60, we're going to get rid of the 0. And in the 495, we're going to get rid of the 5. So now this problem becomes 6 divided into 49, right? So now it's a little bit easier. So now we're going to use our basic multiplication and figure out how many times does 6 fit into 49 without going over. If we count by 6s, we know that the closest number to 49 in the 6 times table is 48. So that would be 6 8 times, because 6 times 8 is 48. So here's my question. We know it's going to be 8. So that 8 is going to be the first digit of the answer that I put down here when I go back to reality, when I go back to the normal problem. The question is, where's that 8 going to go? Well, you do it left to right, basically, and you don't forget the digits that you were at. Let me show you. You got 63. Now you look at the 495 and you ask yourself, going left to right, is 63 small enough to fit in the 4? No, 63 cannot fit in 4. Let's go to the 9. So now I have a 49, okay? And now a 49, sorry, I fell off there. I have a 49. Can 63 fit into 49? No, 49 is still too small. So I go one step further to the 5. Remember, I keep everything I have here. And now I ask myself how many times, well, first of all, can 63 fit into 495? Of course it can. 63 is small enough to fit into 495. So that's where I'm going to put my 8, above the 5, because that's where it starts to fit. Okay? So my first digit of my answer is going to be an 8. Now I'm going to erase my imaginary area right here and get back to the problem. So I have an 8 up here and a 63 down here. What do I do now? Well, now I do what I like to call multiplying around the corner. I'm going to put my little X here for multiplication. And I'm going to put an arrow here. And here's my corner right here. I'm going to multiply around that corner. So I'm going to do 63 times 8. So I'm going to go back to my little side area here and multiply 63 times 8. Okay, let's do this the down and diagonal way. 3 times 8, of course, is 24. Bring down the 4. Carry the 2. Notice I put a little plus sign next to it. Now I diagonal. 6 times 8 is 48. Plus the 2 up here is 50. So I bring down the 0. There's nowhere else to put the 5, so I bring it down with it. And now I have 504. So 504 is 63 times 8. So I'm going to put the 504 down here. Now I'm going to subtract these numbers. I'm going to subtract 504 from 495 and then see what I get. Oh, wait a minute. Hold on. Hold on. 504 is larger than 495. So that's not going to work, is it? Remember, we don't deal with negative numbers in long division right now. So what are we going to do? We have to fix that. How are we going to make 504 small enough to be taken away from 495? Well, there's only one real way to do that. It's to take that 8 and change it. What am I going to change that 8 to? How am I going to change the 8 so that this number is smaller than this number? I have to make the 8 smaller. And I'm going to make it smaller by going 1 less. So 1 less from 8 is 7. I'm going to make this a 7. And that happens a lot in long division. That's why sometimes you have to look back and, take your time and make sure you see what you're doing. And sometimes you have to correct yourself. It just happens that way. But here's a 7. So once again, I'm going to multiply around the corner. Now I'm going to multiply 7 by 63. Okay. So I'm going to do 63 times 7. Oh, by the way, I don't need this 504 anymore. So now what's 63 times 7? Well, 3 times 7 is 21. Bring down the 2, carry the 1, little plus sign. Diagonally, 6 times 7 is 42. Plus this 2 is what? 44. Bring down the 4, can't carry the 4, so I'll bring it down with it. And now I have 441. Looks like a 9, sorry. 441 is now going to go under the 495. So now I have 495 minus 441. Now I can subtract because this number is smaller than this one. So let's do that. Of course, I do right to left. 5 minus 1 is 4. 9 minus 4 is 5. And of course, 4 minus 4 is 0. So there's nothing I can really do. So now I have 54. Okay, so now I repeat the steps. Okay, now I ask myself, how many times does 63 fit into 54? Oh, wait a minute. 54 once again is too small for a 63. It doesn't fit, does it? So now I'm going to have to make the 54 bigger, right? So I'm going to go over here, and I notice that there are no digits here that I can bring down to that 54 to make it a 3-digit number. Is there? No. 54 is where the buck stops, basically. So 54, because 54 is smaller than 63, is going to have to be my leftover or remainder, right? So I'm going to put an R for remainder and put 54. Remember, this right here is really not a 7. This is 7 groups of 63, okay? This is 54 ones. This 54 is what's left over. So basically, if I drew 495 dots and I circled 63 at a time, I would have 7 circles with 54 dots left over. So basically, 63 goes into 495 7 times with 54 remaining or left over. To prove to you that this is correct, I'm going to use multiplication, which is the opposite of division, to check it. Watch what I do. I'm going to multiply 63 times 7 again down here. I know it's a little redundant, but I'm going to do it again. Once again, I know that 63 times 7 is 441. Okay. Now I'm going to add the remainder 54 to 441. You can see that or not. And when I do that, I get 495, which matches my dividend that I originally started with. If those match, I know I did it right. So those are just some shortcuts. Once again, to review, you take the divisor, you round it to the nearest 10 in this case, which I did up here before. Then you take away the ones digits. You divide like regular. You divide like regular. Then you multiply around the corner. If you can't subtract, you make your changes up here. Once it fits and it's small, this is smaller than that, you look at the number that you have left over, your difference. And if it's smaller than the divisor, that's your remainder. If it isn't, you repeat the steps, okay? So those are just some shortcuts to do long division when you're dealing with divisors and dividends of 2 or more digits. I'll probably give you more examples later on in other videos. But for now, hopefully that's for starters, that will help you. And see you later.